Okay, so in this video, we're going to be solving a linear programming problem. And for this particular problem, we're given three inequalities. Y is less than or equal to 40, y is greater than x, and 3y plus 2.5x is greater than or equal to 150. So when we're going to solve a linear programming problem, we want to graph these guys. We want to graph them on a Cartesian coordinate system. But in order to do that, we're going to have to put all of the inequalities in the y form. We want to have y on the left side of the inequality by itself, and then all the other numbers and x's on the other side. So the first two are already in that form, so I'm going to leave them like that. They're good to go. Now let's go ahead and rewrite this guy. I did the work on another piece of paper, but all we're going to do is move this 2.5x to the other side. So we get 3y is greater than or equal to negative 2.5x, and then plus 150. Then we divide by 3. We divide everything by 3. And we get y is greater than or equal to, I'm going to leave this as a fraction just because it's going to make the computation a bit easier. And then this here becomes 50. Okay, so now we have this guy, and this guy. So we're going to graph those three. So let me scoot over here and let me graph them. So start with the y-axis and the x-axis. Okay. And when I'm graphing these, I'm going to go ahead and put my scales here, since the y-intercepts of these guys, like this y-intercept is 50, and the y-intercept over here is 40. So, I mean, I don't have grid paper, so I'm just kind of estimating this. So, I mean, it's not going to come out perfect, but the answer will be the same regardless. So what I'm going to do is put a tick mark and call that one 50, and then I'll go right below that and call that one 40. Okay, so let's graph the first one. Y is less than or equal to 40. So what we're going to do is, remember that this y is less than or equal to 40 is just a line. We're just graphing a line. And this is a constant function. So we're just going to graph a horizontal line with a zero slope. It has no slope. So let me try and do this to the best of my ability. I'm not good at drawing straight lines. Okay. Alright, that's good enough. And then what does the inequality tell us? That y is less than or equal to 40. So what I'm going to do is take another color. Let's use something lighter, like pencil. Yeah, let's use pencil. Because I'm going to shade stuff, so let's see if this works. Okay, good. Alright, so I take my pencil and I'm going to shade downwards because it says, the inequality says y is less than or equal to 40. So less than means that on the y-axis I'm going to be shading down. So let me do that. So I'm going to use my pencil and I'm just shading up. Well, you know what? I don't think you can see that. I'm just shading down with this pencil. Alright, that's all I'm doing because it's less than, so it's everything below the line. Okay, so let's go ahead and graph the next one. So the next one says y is greater than x. So if you were to graph this as a regular line, how would that look? Well, it would just look like the line y equals x. So let's go ahead and graph that. So it's just going to be a line with a slope of 1, and it crosses right through the origin. So let me go ahead and try to draw a line there. Okay, I guess that's good enough. Good enough for me. Alright, there is one thing that's important. It says y is greater than x, but not equal to x. So technically what I did here, and I overlooked this detail, your line should actually be dashed, not a solid line, because it's strictly greater than. Anyway, that was just I'm not gonna erase that. I can't actually erase that. I'm not gonna start over again. So just pretend that the line I drew here is dashed. It doesn't actually change the final answer or anything like that. Anyway, it says y is greater than, right? So y is everything that's greater than this line that we just graphed. So I'm gonna shade, I guess I'll shade in a diagonal like this, like that, up. So greater than. I'm gonna shade like that. Okay. All right, great. Now let's graph our third one. And our third one is y is greater than or equal to what? Negative 2.5 divided by 3x. I don't know if you can see that or not. Okay, negative 2.5 divided by 3x plus 50. So, let me go back to our graph. The y-intercept of that line is at 50, so it's up here. And it has a negative slope. So this one is going to look, again, I'm just approximating. So I don't have like a ruler or graph paper or anything like that. So let me just approximate this. It's going to be something like that. Yeah, something like that. Of course, when you do this on graph paper, it'll come out much nicer. Anyway, let me go ahead and zoom in here. I want you to see. Okay. And what does the inequality tell us? That y is greater than or equal to. So we just graph that line, and then I'm going to shade this way, like to the right. Now, I know this is kind of messy. There's shading all over the place. But what we're interested in is the small region where all three shadings overlap. So we had said that y is less than this line. We had said y is greater than this line, and then y is greater than that line. So that little region is right here, this triangle right there. So to make life easier, I'm going to go ahead and just color that triangle with purple. Let's see. Okay, purple. Alright, so that's the region that we're interested in. This region is called the feasible region. The points in this region are going to satisfy all three linear inequalities. So I want you to take a good look at that triangle. It's a very important region. Okay, so it's a triangle, and there are three vertices. So right here at the top corner, another vertex right here, and then another one right here. It's where two of the lines intersect with each other. So three vertices. And the question was asking us to find one of them. No, actually to find all three vertices. So the next step, I already graphed it. The next step is to find the vertices. So remember that a vertex of the triangle is where two of the lines intersect each other. That's a vertex. So to solve this, like you see how two lines intersect right here at the top right? I'm gonna solve this and get the coordinates of this vertex. So to do that, I have to find which two lines intersect. So it was this guy, which is y is less than or equal to 40, and the other line was y is greater than x. So what I'm going to do is set the two inequalities equal to each other and solve. So I'm going to say, remember, we're using the one on the top, y is less than or equal to 40, and we're using the one under it, y is greater than x. So I'm going to set them equal to each other. So I'm going to say 40 equals x. I'm not going to worry about the y part because that's what we're using to set them equal to each other, because they both have the y in common. So I'm going to say 40. Oops, can you see that? I hope you can see that. 40 equals x. Aha! And guess what? This was pretty easy because we already have the solution. The solution is 40 equals x. That was pretty basic. So let's go back to our graph. Let's go back to our graph. And that point is up here, this vertex. And let me see, I'm going to write them on the right side right here. I'm going to call it V1, vertex 1, and it equals to 40 for the x. And what do you think the y is going to be? So on the x-axis, it's 40. So what is it on the y-axis? Well, it's got to be 40, because 40 is the only number that satisfies this linear inequality. So the y has to be 40. I mean, I'm not saying, I'm so sorry. I'm saying that if you look at this as a function, as just a y equals 40, 40 is the only value. It's a constant function. That's what I meant to say, not what I previously said. What I previously said was actually a false statement because the number 39 satisfies the inequality. Sorry, I got my words jumbled up there. Anyway, so where were we? Okay, so x is 40 and then y is 40, so let me do that here. Alright. I think I need to invest in a better camera or something. Not sure. Okay, anyway. So, let's sit back over here. Now we've got that one. That was the vertex that's on the top right side. That's this guy. Now we need to, you know, it looks better if I hold it over here. Okay. So that was the top right side. Now we need to find this vertex. I mean, you can find them in any order, doesn't matter. But let's go ahead and find the one down here. So that vertex, we're going to set, what are the two lines that cross each other there? It's y is greater than x, and then the other one is this long one that we have over here. This y is greater than negative 2.5 x over 3, I mean negative 2.5 over 3x plus 50. So we have to set those two equal to each other. So I'm going to do that right here. So I'm going to get, hope you can see this. What was it? X, yeah. X is equal to negative 2.5 over 3x plus 50. So I hope you can see that. Yeah. So all I'm doing is I'm just setting the two inequalities equal to each other. Then I'm just going to solve. So I'm going to move, when I solve, of course, I'm solving for x, right? That's the variable here. So what I'm going to do is move this guy to the other side. And this part is just basic algebra. So I get plus 2.5 over 3x plus 2.5 over 3x. Oops, okay. Then when I add them, I did this, you could just do this in the calculator. I did it on another piece of paper, so I don't have to take up too much time, but it's actually just, it comes out to, let's see, it comes out to, where did I get here? Yeah, 5.50 over 3x equals 50. And so when you're doing this, remember that there's a 1 in front of the x, so you're doing 1 plus 2.5 over 3. So you can rewrite that 1 as a fraction 3 over 3. That's 8th grade math. I'm not going to get into that. So this is what I get now. And then I'm just going to multiply both sides by 3. So times 3 times 3. And I get 5.50x is equal to 150. And then all I'm going to do next is just, oops, can you see that? Yeah, all I'm going to do next is divide by 5.50. And then I get x is equal to 27.273. So I'm just rounding. I just rounded that guy. 27.273. Okay. So that's our x. And remember where it's going to go? It's going to go, it's the x coordinate of the vertex right here. So maybe to make life easier, I'm just going to write it right there. 27.273. There you go. And then, what would the y be? Remember that this line is just y equals x. So y would just be also 27.273. Because 27.273 equals 27.273. Remember, this guy is the what you call the identity function. This line right here. It's the identity function. So we found the second vertex. Let me write them over here. V2 is equal to 27.273, comma 27.273, and then I'm just writing it there. So we've got two vertices. Now we need the last one. The last one's going to be pretty easy. All right. So what two lines intersect at that vertex right here? It's y is less than or equal to 40, and the other one, the one with the two terms. Okay, so let's solve that one. Let me write it over here. So we have 40 is equal to, again, I'm going to use this guy, the one with the two terms. So that's negative 2.5 over 3 times x plus 50. Okay, and I just have to solve that. So I do minus 50. Okay, minus 50. I get negative 10 is equal to negative 2.5 over 3x And then the rest of this is pretty basic. I do times 3. Times 3 is just basic algebra. Algebra 1, it's not even algebra. So then negative 30 is right here, and then we get negative 30 equals negative 2.5x, and then we just divide here by negative 2.5, and then divide over here by negative 2.5, and we get negative 30. Can you see all that? Take a good look at that. Just want to make sure that. Okay, so the next step is dividing right here, and we end up with positive 12. So positive 12 is equal to x. We got that. And where is that going to be here on the graph? Well, it's going to be, remember, we're finding the vertex of up here, the top left one. So for the x, it's, oops, my fountain pen is running out of ink, so bear with me. So this is 12. And what do you think the y is going to be? Well, this line is always 40, so the y is 40. It's a constant function. So that's pretty easy. So let me write that here. So the x is 12, the y is 40. In case that didn't seem clear to you, just look at it again. The vertex is on this line, y equals 40, right? And on the other line. And we found that x is 12 there. Y has to be 40. The line crosses right through it, and it's always 40. So that's where I got y equals 40, and that's why I put it here in the y. All right, so we're done. Well, actually not yet. We're almost done. We found the 3 vertices of the feasible region. Let me box that in. All right. 3 vertices of the feasible region. Take a good look. All right. Good. Now, the very, very last question was about, it was asking, because it was a word problem, and it was saying something like, let me see if I remember this. It's saying something like, so y represents pi, like the number of pies the baker is going to make. X represents the number of cakes the baker is going to make, and it just has to satisfy these 3 inequalities. I think that for the third one, he has to make at least $150 to pay the rent of his bake shop or whatever he has. So this last inequality is going to be super important because we want it to be either equal to or larger than 150. So the question says to find 2 possible combinations of pies and cakes that the baker can make. Okay, great. So let's do that. Can we use any of our vertices? Would any of these count? Well, first let's notice that the first one is 40, 40. They're the same. And the second inequality says that y has to be strictly greater than x. So they can't be the same. So actually the vertex is not going to work for, my leg fell asleep. The vertex is not going to work for this particular inequality because it's actually not defined at that point. Anyway, I don't want to get too much into the mechanics there. As long as you see that 40 is not greater than 40, it fails to satisfy that inequality, so we can't use that vertex. And the same is true about the one right under that, because that one says that 27.273 is equal to 27.273. So that doesn't work either because they're the same and one has to be larger than the other. Well, actually, the y has to be larger than the x. How about the third vertex? X is 12, y is 40. Well, all we need to do is check if it satisfies the 3 inequalities. So is y less than or equal to 40? Yes, it's equal to 40, so that's true. Is y greater than x? Yes, because y is 40 and x is 12. Then the third thing we need to check is this one. It is 3 times 40 plus 2 times 2.5 times 12 greater than or equal to 150. Just type that in the calculator. I'm not going to spend too much time on it, so just type, yeah, all you're doing is just multiplying here like this plus 2.5 times 12, and we're saying is that greater than or equal to 150. And actually when you type this in the calculator, it comes out to almost exactly 150. It's gonna be or you know what, I think it does come out to 150. You can just check it. Either it is 150 or it's slightly larger than 150. So this is true. So we can use that vertex. So we already found one point or one combination. So we'll say for the first, I'll write right here, first combination. Let's see, it's going to be 40 pies and 12 cakes. So I can just start putting a box around that. And then the second combination, you don't have to pick points that are vertices. You just have to pick points that are in the feasible region. So like, let's see, you have up here, you see how like 40 doesn't work because they're the same? Well, we can easily fix that. All we need to do is change the x to 39. So we're gonna, yeah, because see, where does that lie? That would be like 39, it would be right here on the graph. X would be 39 and y would be 40, so it would be like right there, somewhere like up here. Anyway, you can check if that works. So second combination, we're gonna check, it would be 3 times 40, because y is 40, plus 2.5 times 39, and oops, can you see that? Yeah, 3 times 40 plus 2.5 times 39 is greater than or equal to 150. So let's check if that's true, and actually yes, it's going to be true. I don't even need to check the calculator. How do I know? Well, if this is true, notice that we're plugging in a 12 for the x. Now we're plugging in a larger number, 39, and we're multiplying it by 2.5. So if this is equal to or larger than 150, then this is definitely way larger than 150. You can just see that. This is just from the logic right here of the numbers, just the logic. So that's going to work. So then the second combination would be he can make 40 pies and 39 cakes. And that does satisfy all our inequalities. Y is less than or equal to 40, that's true. Y is greater than x, that's true because 40 is strictly greater than 39. And then we check the third inequality and we get that this is also true. So there you go. These are two possible options that the baker can use. He can either make 40 pies and 12 cakes or 40 pies and 39 cakes. Alright, I hope you enjoyed this great math video. Here's another view of the wonderful triangle that we had to graph here. And alright, have fun with math.